Hello everybody. In this chapter, we will study circuit analytical technique. Previous chapter we have studied the basic law like Ohm's law, Kirchhoff voltage law, Kirchhoff current law. Now in this chapter we will study a bit more technique on a few number of techniques for circuit analysis which will be used in DC direct current circuit. Among them are branch current analysis, mesh analysis, and nodal analysis. First, let's go to branch current analysis. So let's say we go to example 3.1. Let's say we have how many? We have in this case we got two loop. This one loop. This is a two loop circuit with what? With I1 flow through branch between AB. This branch, this one branch, AB find current in I1 branch, this one, and branch BC find current I2. Then branch BD find current I3. So this is current analysis technique, current analysis using branch current technique. So that we want to determine the current in each branch, I1, I2, I3, using branch current analysis. So first we loop A, this loop ABD is here, is this one. ABD is this loop. ABD is this loop. Using Kirchhoff voltage law. Current here, E1 equals to voltage supply equal to I1 times R1. Voltage drop across 2 ohm is I1 R1 plus I3 R3. This one. Supply voltage equal to voltage total voltage drop. Supply voltage 2 ohms, 2 ohms, I1 2, 4 ohm, R3 4 I3. Next, we loop for next loop. This loop. Next, we do for second loop. Loop BCD. So this one same. This loop. Supply voltage 6. Then I2 1 ohm. I2 1 ohm. Then drop one I3 R3. I3 R3 is 4. Okay. Then another, this is a 3 variable, 1, 2, 3 variable. We got 2 mathematical equations, not enough to solve. So we need another variable which we study, which we use Kirchhoff current law at what? At this node. At this node B. Current inside is I1, I2. I1 plus I2. I1 plus I2 equals to out current, I3. So we solve this mathematical equation, we have this answer. So other technique to solve this one, next second technique to solve this one is what? Is using mesh current analysis. This is voltage source. Mesh current analysis. Same circuit. We do mesh current analysis using mesh analysis. Same circuit as this one. Same circuit. This one use branch current technique. In this one we use what? Mesh analysis. So we draw one mesh. Here one mesh. Voltage drop blue one, V3, V1, E1. Then 6 volt, V2, V3. This direction. The mesh 1, this mesh. So supply, this one, supply resistance is E minus 2, E2 minus 2 plus. This one total one, I1 is here, this one I1 is here, this one I1, this one I2. So I1 flow to 2 ohm, then 4 ohm. So total is 6. 6 I1. Then this part, this 4 ohm share with I1 and I2. This one direction positive, this direction must be reverse, must be negative. So minus 4 I2 equal to 0. Then mesh to this mesh. This mesh. Oppose. This one is oppose. This direction here, oppose direction is plus 6. Plus 6. Plus 6. Then this one, oppose. Oppose. I2 is 4 plus 1, 5 I2. 5 I2 positive. Then this part share with other. 4 ohm share with I1. Minus 4 ohm I1. Then 2 equations. In solving these 2 equations, I1, I2, we got I1 minus 1A, I2 minus 2A. Then current through R3 here is what is I2 this direction up I2 minus I1. I2 minus 1 plus 1. Minus I1 is minus 1, so it's plus 1, so it's minus 1. So current through R3 is minus 1 ampere. Note that the negative sign, this negative sign indicate that the flow of current is in opposite direction of direction stated in the figure. Example 3.3. We also use what? Mesh analysis. But now, we want to find current through R2, red one. Now find this current through R2. Now, we got this one. This is current source. Current source with a parallel resistance 2 ohm. Current source. Mesh analysis, you see here, mesh analysis. We got 2 what? All are voltage source. This one voltage source. So we need to convert this one, convert this voltage source, this current source to this voltage source. Like we cover in chapter, this called source conversion. So this voltage E1, this pointer up, it is minus plus, the pointer up, plus in this long, let's say in this direction. This one is the long, pointer, so this one is long. Then 2 ohm parallel become series 2 ohm. Then this one change to here. 6 times 2, 12 volt. Okay? Then become 2 voltage source. Next, we use mesh. This mesh 1. This one mesh. This one mesh. Another mesh is here. Another mesh is here. Okay? So this one mesh parallel is I1 is 2, 4, 10 is 16 I1. 16 I1 16 10 4 2 16 I1. Let's share it around here opposite loop. Opposite is minus 10 I2. Minus 10 I2. Since this I said supply one is equals to 12. Equals to 12. Then I2 rearrange become here. Then mesh 2. Mesh 2 is I2. I2 10, 5, 15 I2. 15 I2. Opposite direction 10 ohm. I1 opposite. 10 minus 10 I1 minus 10 I1 minus 10 I1 equals to equals to equals to this one, of course 20 volt. 20 volt. So equate I2. Find I1. I1 is this one. I1 is this one, same as same as this I. Okay, so find equate I2, these two are equate, so we got 2.7 ampere. Then this mesh analysis, another technique for mesh is super mesh. Super mesh, we do what? Two loop, two mesh, but this part is what? This share one is a current source. This one share one is a voltage, is a resistance, but in this normal mesh analysis, mesh analysis is this part share one is what? Is a current source. So we add what? This direction is I1 minus I2 equal to 4. I1 minus I2 equal to 4, same as I1 equal to 4 plus I2. Get one equation here. Then we take this one out. Current source we take out. Then we become here. So we draw this one. Super mesh. Whole thing here. E1. Then this drop. This one is 10 I1 plus minus 2 I2 plus what? 12. So equals to here. Solve these two equations. We got I1 3.33. Find what? Find resistor R1. Find this current through resistor R1. This one. Find this one. So I1 equals to 3.33. Next, nodal voltage analysis. Nodal voltage. Next, we go to nodal voltage. New technique. This one is one node. This one another node. So here we label here. Node this part, node V1, node V2. Then we label current. Label the current this direction, I2. Here I1. Here IS1, this one, I1. Then this one, come to here, I3. Label the current properly. Then do the what? Do the using KCL, Kirchhoff current law, at node V1. V1 sum of current inside here is what? IS1 equals to out I1, I2, IS2. Then I equals to I1 is V1 divided by R1. Then I2 is V1 minus V2 divided by R2 plus IS2. Substitute the value. We got one equation. Next for node V2. Node V2 is here. Node V2 is here. Sum current here. And I3. I2 plus I2 equal to I3. I2 plus I2 equal to I3. I3 equal to I2 plus I2. I2 plus I2. Then I3 equals to I3. I3 equals to V2 divided by R3. V2 divided by R3. V2 divided by R3 equals to IS2 plus I2 is V1 minus V2 divided by R2. I2 here is this one. I2 here is this one. I2 this is V1 minus V2 divided by R2. The I2 is 2 ampere. Substitute here we got another equation. Let's solve equation. This one and this one, we get this value. Okay? Then using nodal analysis to find voltage V6 for the ladder network. Ladder network is what? Is this one. Got one section L section S. This is called ladder network. So first label node voltage. Find V6. Find V6. We want to find V6. V6 is here. V6 is here. So V6 is here. So same as put the label here, same as what I find this one, V3. So I find V3. So this one. So for this, see, we apply the procedure. This one all change to what? Change to current source. change to current source, so we change this one, change this one, change this one, voltage source change to current source. 5 ohm, you set this one, 5 ohm, connect back to here, 5 ohm. Then this one pointed up, so it's current like this, pointed up is 24 divided by 5 equals to 4.8. 24 divided by 5 ohm equals to 4.8 ampere. Then 5 ohm, current source parallel, then the rest here attach back to here. Then label I1, I2, I3, I4, I5, I6. Label. Then note V1 is I, using Kirchhoff current law, I inside note I, this one is I equal to I1 plus I2 plus I3. I1 plus I2 plus I3. Then substitute all the voltage value, we got equation 1. Then note V2 here, V2 is what? I3 equals to I4 plus I5. I3 equal to I4 plus I5. Then substitute all this value, we got here. Then V3 is here, we got I5 equal to I6. I5 equal to I6. I5 is V2 minus V3 divided by R5 equal to V3 divided by 6. So you got this one. Let's simplify to resistance value, we got here. So 1, 2, 3, we solve for what? Solve for V3. We want to solve for V3. Then after solve V3, we get what? V6. Solve for V3, you can say 1, 2, 3, solve for V3. If you solve for V6, V3, so V3 equals to 2 volt, V6 also equals to 2 volt. Okay? Next is supernodal analysis. Just start supermesh. Now specifically our knowledge is supernodal analysis. Same, the nodes there, 2 node, one is a voltage source. Just sound this one. Just sound this one is what? Supermesh. Just sound this one, supermesh. Share current is share current source here between two share current source. Now supernodal. Share current, share voltage source between two nodes. Then form the short. Plus is V1 minus V2 equal to 12. Is V1. So it's V1 minus V2 equals to E. E is 12. So 12 equals to V1 minus V2 because it's long. Long is positive. V1 minus V2 V1 minus V2 equals to E, 12. Then take out solid. This T1 single node is super node. Let's take this node as super node. Label the current or take out the voltage source, solid. Then label all the current I3, I1, I2. This one is current source, doesn't matter. Current inside this node is minus IS1. Then current flow outside I3. Then come back, current flow outside, come back to same enter the node again. So it's another one is minus I3. Then out I1, I2, I1, I2, all plus. IS1, 6. Substitute all this value, we got 2 equations. Then V1, V2, we can solve for V1, V2, 12 here, one equation 1. And equation 2, we solve it, we get this value. Okay? After that, we will go to tutorial. So we will cover this topic in detail in full lecture. In full lecture, we will cover this one in detail.